Hello, College Algebra, and welcome to Chapter 6. So you should have, it's a purple packet in front of you. It's Chapter 6 called Matrices, and I think you're going to enjoy this. It's quite fun. All right, so get everything ready, and let's go. All right, when you're going through here, whoops, excuse me. I need to flip this so I can write on it. Sorry about that. Okay. We're going to solve equations using matrices. We're going to use an augmented matrix is what we're going to look at. We're going to perform matrix operations, which you have to do in order to solve matrices. We're going to use a Gauss elimination just to show you how it works. And then after we have the Gauss elimination, we're actually going to finish it using the Gauss-Jordan elimination method. So this here you will never have to do on a test. You have to do it in order to finish this guy because it's the first half, but that's the only reason. So step one is, can you read a matrix? And a matrix is just a rectangular array of real numbers. Okay, there's an entry. So like 6 is an entry, 7's an entry, 10's an entry. It's just the numbers or the equations that are in the matrix. It is read, rows, and then columns. Rows are horizontal, columns are vertical. So this is a row, and this is a column. All right, when you read this matrix name is C. He's a 3 by 4. Okay, that means we have 3 rows and 4 columns is how that's read. C is just the name of the matrix. They're always capital letters. All right, this is very different than a 4 by 3. That means you have 4 rows and 3 columns. So this guy's name is D. He is a 4 by 3, and you have to know where these are because this is how we're going to multiply later. So this is row 1, column 1, right? Row 2, column 1. So this guy here is row 3, column 1. Row 4, column 1. Now if you go down here, finish filling those in. Pause and do that. Okay, here you should have said, hey, that's row 2, column 2. This guy here was row 4, column 3. I hope you did well. Okay, here's my matrix. Pause and fill this in. His name was D. His size is a 3 by 2. Row 2, column 1. So row 2, column 1 is 4. Row 1, column 2 is -2. Just can you read a matrix is what we're looking at right here. All right, when you write an augmented matrix, everything has to be lined up in order. So just like before, we're going to place the coefficients in the matrix. So we are not going to use the variables. And if missing a variable, we're going to plug in 0. This is just how do you write it so we can do operations with it. So up here, these are my 3 equations. That means I'm going to have a 3 row and 3 columns. So we go 1, -4, 3. My first row. Your second row represents your second equation. So it's a -1, 3, -1. Your third row represents your third equation. Now be careful here, you're missing the y. So you put the 2 in for x, there's 0 in for y, then -4 for z. Now when you go through here, an augmented matrix, this is supposed to be a solid line, Word would not do that for me, is where you just put the answers in the remaining column. All right, it's not actually considered the size of the matrix, but it's how we work with this. So this is still 2, 0, -4, and then the 6 is the answer or what it equals. Those are the augmented. We will be using those quite a bit. All right. Go on to the next page. These are the operations you can do with a matrix, and you can't do anything else. You can change 2 rows, so I can just flip them around. It would be like flipping the order of the equations, so that's no big deal. I want to interchange row 2 and 1. That means I want to take these 2 rows and flip their spots. So -1, 3, -1. I just moved this row up here. 1, -4, 3 became my second row. 2, 0, -4. Seems pretty elementary, right? Very helpful at some place. Okay, I would like you to take this exact matrix right here and interchange row 1 and 3. Pause and do this. Okay, so if you interchange row 1 and 3, 3 now becomes row 1. 2, 0, -4. Row 2 does not change, so we leave him alone. -1, 3, -1. And then row 1 becomes your row 3. 1, -4, 3. I hope you did a great job. Okay, we can multiply any row by a number. That includes a negative. All right, so I want to multiply row 2 by 2. That just means I take every element in row 2 and I multiply it by 2. So row 1 stays the same. We do not change him. Row 3 stays the same. We do not change him. We take row 3. Row 2, we multiply it by 2. That's how we get the -2, 6, -2. All right, I would like you to take this matrix, the original, right here, and multiply row 3 by a -1/2. In other words, you're dividing, but that is not technically legal. So we multiply by a -1/2. So you're taking row 3 times a -1/2. Go. Okay, since you did not change row 1 and 2, they stay the same. Row 1 and row 2 have not switched. Row 3 times a -1/2, so 2 times a -1/2 is -1. 0 times a -1/2 is 0. -4 times a -1/2 is 2. And you have now performed multiplication. You can multiply row 2 by 2 and add it to row 3. When you do this, the only thing that changes is row 3. You don't actually change row 2. So to help me do this, generally I take the row I am multiplying and I write little numbers above or below it. So I have to take row 2 times 2. That means -1 times 2 is -2. 3 times 2 is 6. -2 times 2 is -2. Now I'm going to take those red numbers and add them to row 3. This means row 1 stays the same. Row 2 stays the same, because the operation is what I add to. So row 3 is the only one that changes. So -2 plus 2 is 0. 6 plus 0 is 6. -2 and -4 is -6. Okay, your turn. I want you to take the original matrix up here. So this is the one you're working at. Multiply row 3 by a -1/2 and add it to row 1. Go. Okay, when you did this, the only row that changes now is row 1. This is the only row that's going to change. So you should have put little numbers underneath row 3. So 1/2 times a -1/2, -1, 0, 2. So now we're adding the blue numbers to row 1. So -1 plus 1 is 0. 0 plus -4 is -4. 2 plus 3 is 5. And then row 2 and 3 stay the same. We are not technically changing them. We are only using row 3. We are not changing its values. Okay? All right, this one here is called Gaussian elimination. It's the first half to Gauss-Jordan. And we're going to use this to solve for variables. So my answers are actually going to show up right here when we're done. Okay, step 1 is we write our matrix just like we did before. And then the goal is to get the diagonal to 1 and all these numbers down here in my triangle to 0. And then the Jordan part will replace these numbers with 0. So this is, we have to do the first 2 first and this guy last. All right, but we don't get all 1s first. If we get all 1s first, we have a tendency to go in circles and never be able to solve. So the goal is to get the first a 1, and then we go down to the second row and we get this guy a 0 and this guy a 1. And then we go to the third row and go 0, 0, 1. It doesn't have to go in that order, but usually it works fairly well. All right, so our first example 1 is already done, so I don't have to do anything. So now I move down to my second row. I need to get this -1 a 0. To do that, I only get to look at this column. So which one of these numbers, 1 or 2, will help me get -1 to a 0? Well, if we take 1 plus -1, we get a 0. So what we're going to do is we're going to add row 1 to row 2. So we're adding row 1 to row 2, which means I am replacing row 2's value. So 1 stays the same, write him down. 3 stays the same, write him down. So now we're going to add 1 plus -1 is 0. -4 plus 3 is -1. 3 plus -1 is 2. And we still have to do it to the answers. 5 plus negative 3 is 2. Okay, we've got our 0. So the next one we need to look at is this negative 1. And he needs to become a positive one. We're just working in order here. Down and then to the right. Well, that's pretty easy. I just got to multiply this guy by negative 1. So 0, first row stays the same, last row stays the same. So we got 0, 1, negative 2, negative 2. All right, we got my 1. I got my 0, 1. Now we go down to my next row, because remember these guys over here are last. So I need to make 2 a 0. Again, you're looking at this column. What will help me get 2 to a 0? And you can't multiply by 0 because that takes out the whole row. So I have to use the 1 and the 2. So in order to get this to a 0, I have to take negative 2 plus 2. That means I have to multiply the first row by negative 2 and then add it to my last row. First row stays the same. Second row stays the same. So now we're going to multiply by negative 2. So this is going to give me negative 2, 8, negative 6, negative 10. Now I'm taking the blue numbers and adding them here. Negative 2 plus 2 is 0. 8 plus 0 is 8. Negative 6 plus negative 4 is negative 10. Negative 10 plus 6 is negative 4. We're doing pretty well. All right. Now we need to go down to, we've got our 1, 0, 1, 0. Excuse me. Now we have to get this 8 right here to a 0. Now again, we're looking at this column. At first you would think negative 4 would be an awesome bet because I just multiply by 2. But if I multiply by 2 and add down, I'm going to change this 0 to a 2, and I don't want to do that. So since I don't want to change this guy, I'm only allowed to use this one to get rid of him. So to do that, I'm going to have to multiply by a negative 8 and then add it to the third row. So row 1 stays, row 2 stays, nothing changes. So now I got to multiply by negative 8. Let's get rid of some of this in here. So when we multiply by negative 8, this is negative 8, 16, and 16. So negative 8 plus 8 is 0. 16 plus negative 10 is 6. 16 and negative 4 is 12. We're doing well. Next, this one has to be a 1. The easiest way to always get him to a 1 is to divide, or multiply, in this case, by a 1, 6. So I'm not changing row 1 or row 2. Dividing both of these by 6 gives me 1 and 2. All right, we have our zeros. We have our 1s. We have done the first half of Gauss-Jordan. Okay, this bottom part is just to show you what you have. So this is x minus 4y plus 3z equals 5, right? This is y minus 2z equals negative 2, and this is z equals 2. Now you know, by using substitution, you would take this guy and plug it in here and solve for y. And then you would plug in z and y and solve for x. That's what all of this is. So we're going to use that same logic to finish solving this using matrices. Now we're going to work backwards. So we're going to get this negative 2 to a 0. So instead of working right and down, we're going to work up and left. And then we have to get both of these to a 0, and actually it doesn't matter which order we do those. Okay, let's continue. Here is yours. I would like you to stop and use Gaussian elimination, so your 0s and 1s, and see if you can get this guy done. Okay, I hope you tried that. The good thing and the bad thing about matrices is there's multiple ways to do them. So you could have done it like I did, or differently. The only thing that matters is at the very, very end what z equals to. So what I did first is I switched row 1 and row 3. So I just put row 1 up here and row 3 on the bottom. I just moved them around. So I got my 1 up here, which is what I needed. So now I looked at here and I needed a 0. Again, looking at this column. To get a 0, I'd multiply this one by negative 1 and add down. So I put my little numbers in green up here. Left row 1, left row 2, because they didn't, row 1 and row 3 did not change, so I just wrote those down. Negative 1 plus 1 was 0. Negative 2 and negative 1 is negative 3. 1, 2 is 3. Negative 6 and 9 is 3. Well, this one was nice because all of these were 3's. And I just need to get him to a negative 1. So I divided everybody, or multiplied everybody by a negative 1/3. So row 1 did not change. Row 2 did not change. Row 3 became 0, 1, negative 1, 1. So we're doing really well. We've got our 1, our 0, and a 1. Next, I needed to change the 2. So again, you're looking at this column. So in order to get this guy to a 0, I multiplied this one by negative 2 and added down. So multiply by negative 2, add down. So row 1 does not change, row 2 does not change. Row 3, negative 2 plus 2 is 0. Negative 4 and 1 is negative 3. 2 and 2 is 4. Negative 12 and 18 is 6. So we're doing really well so far. So now I need to get this guy to a 0. Again, I'm looking at this column. So I'm going to use the 1 and multiply it by 3 and add it down. So that's where these little red numbers came from, and that's 0. Add down, we get 0, 0, 1, which was really nice, and 3. You could have done this differently and have different numbers in row 1 and row 2, and it's still right. The only thing that has to be exactly the same is z has to be equal to 3. If z does not equal to 3, then you have done something wrong. Go back and check your math. It's usually a negative mistake. All right, now to continue. This is the one where we left off before. Remember, we had our 0s and our 1s. Now our goal is to get these to 0s. So to get those to 0s, I'm going to look at the 2. So this is the one that needs to change. You have to look at this column again, and this time we're working upward. So what can I multiply 1 by to get negative 2 to 0? So I got to multiply this row by 2 and add it up. So row 1 stays, row 2 stays. So this becomes a 2 and a 4. 2 plus negative 2 is 0. 4 plus negative 2 is 2. So right now I've got z equals 2. Y equals 2. Now I have to get rid of both of these. It does not matter which order you do them in. It's completely irrelevant. You can do the negative 4 or the 3 first. You will get the same answer. I just chose negative 4 because it was first. So I had to take 1. So I had to multiply this row by 4 to get this to 0 and add it up. So this is 4, 0, 8. So 3 stays, 2 stays. 4 and negative 4 is 0. 0 and 3 is 3. 8 and 5 is 13. Next, you have to get the 3 to a 0. So I'm going to take 1 times negative 3. So I'm going to multiply this guy by negative 3 and add it up. So 0, 0, negative 3, negative 6. Add it up. So first thing I do is I wrote down row 2 and row 3 because they do not change. 0 plus 0 is 0. 0 plus 1 is 1. Negative 3 plus 0 is 0. Negative 3, I'm sorry, that was negative 6. Negative 6 plus 13 is 7. So the answer I get is x is 7, y is 2, z is 2. Written as a point because it's actually 3-dimensional. And we're done. What I would like you to do now is you're going to finish the one that you started. I gave you the answers. This should have been brackets where I started, and I want you can either start there or start. It doesn't matter which one you start with, the one you had or the one I had. And now your goal is to get all of these to 0s. Good luck. Okay, I hope you did a good job. I'll show you what I did. Remember, you can do it any order you want. The first thing I got rid of was this negative 1. So I took this row and added it to this row, which means row 2, and row 3 stayed the same. 0 plus 0 is 0. 0 plus 1 is 1. 1 plus negative 1 is 0. 3 and negative 1 is 2. Now I chose to get rid of this one. So I took the second row and I just added it to the first row. Okay, that means the third row, the second and the third row stayed the same. So I wrote these two down. 0 and 1 is 1. 0 and 1 is 1. 1 and negative 1 is 0. 0 and 2 is 2. 2 and 9 is 11. Next, I had to get rid of this guy. So that means I have to take the bottom row times negative 2. So that was 0, 0, negative 2, negative 6. So I have to add these up to the first row. So Third row, second row stay the same. 0 and 1 is 1, 0 and 0 is 0, negative 2 and 2 is 0, negative 6 and 11 is 5. So your answer is 5, 2, and 3. Okay, I hope you do well. If you have questions, make sure you're posting them on the discussion board, and good luck.